Okay, Chapter 11, Standard Costs and Variances. This chapter has a lot of learning objectives, but there are really just two big things in here. Is first of all, understanding what a standard cost is. All right, it's actually really easy, but you've got to think about it a little bit. And then we're going to look at variances for direct materials, direct labor. Okay, look at some of the advantages and disadvantages of using standard costs and variances. And then the last piece is to look at overhead. So first, why and how standard costs are developed. And what a standard cost is like a budget. You can think of it like a budget that was developed by engineers, okay, for a single unit of product. And we develop standard costs for each type of product. We don't actually use like actual costs for a unit. And there's an example in the book about Coca-Cola saying that they sell 1.9 billion products per day. You see, so I mean, it's just so unwieldy that a standard in many ways makes sense. And then what we do is we look at the variance. Okay, what changes from what the plan was for a particular product. Service companies use standards too, like all hospitals are all built on standards, and the standard becomes the benchmark, okay, against which we evaluate the actual cost. Okay, so a standard cost is just developed as the most reliable number we can for what it costs to compute or to manufacture one product. Now we've got three different ways that we can look at this. We can have ideal standards, when everything is perfect, okay? If everything's perfect or ideal conditions. In other words, everybody works 40 hours a week, full-time, and nothing ever goes wrong, okay? And then there's something called perfection standards. So that's ideal. These are perfection. Perfection standards do not allow for any poor quality raw materials, waste, machine breakdown, or other inefficiencies. These are lean production systems, okay? But that's still difficult to attain. But practical or attainable standards are based on what conditions are now, and they allow for normal waste inefficiency. Okay, sorry. Okay, so those are things that you can just plan on, like you know yourself, even when you work, when you're going to do a day's worth of homework, there are only so many hours that are really good. All right. Ideally, you could work at full speed with total concentration for 12 hours a day. Well, you can't really do that. Okay, there's something that's more attainable. That's more like 30 minutes. Okay, and what do we use to do it? We use past material and labor usage. Okay, we look at history, the current cost of what the inputs to the system are, estimated future changes. All right, like right now, can you imagine the changes in costs that we've got going into the future? Especially when you've got to, you've got all the security and all the hand sanitizer that you have to buy, and also the time and quantity that should be needed to produce each unit. Okay, that's the information that we need. So here's which of the following is true here. Ideal standards are based on currently attainable conditions. Okay, practical standards are ideal. Those don't sound right, do they? A standard cost is the budgeted cost for one unit. That's pretty close. I think that looks pretty good. Standards should never be updated. Excuse me, and that's not true. Standards should be updated all the time. Probably maybe once a year, okay, at least, or if there are any changes, any significant changes that happen, then you would update the standard. Now we compute standard costs for direct materials, direct labor, and also for manufacturing overhead. And for overhead, we divide it into variable and fixed. And the formula for doing this would be a standard quantity of direct material times the standard price of direct material gives us the standard cost of direct material. Okay, so it's broken down between price and quantity, okay, or quantity and price. So this Tucson tortilla requires 5 pounds of flour at $1.50 a pound. So what's the standard? 5 pounds times 1.5 a pound, $7.50 per case. One of the things you've got to watch though doing these problems is see how this, say 5 pounds of flour at $1.50 per pound, but they don't tell you that this is what's required for a case. Watch the unit on this, okay? So in this case, the unit is a case, okay? Direct labor, standard quantity times standard price. Okay, the price in direct labor is frequently called the rate. The quantity would be hours. All right. When you go to, let me just go up here. When you go back to direct materials, the quantity may be pounds, for example, okay, or maybe an actual count of something. But for labor, it's going to be hours and rate. And that'll give us our standard costs for direct labor. So Tucson tortilla requires 0.05 direct labor hours per case at $22 an hour. So 0.05 hours times $22 per hour is $1.10 per case. Okay, but notice how it's going to be hours per hour and then case. So watch your units there. Okay, now materials overhead. Okay. Just you can look at these. We're going to break it apart between variable and fixed. So the total estimated variable be divided by the allocation base gives us a variable manufacturing overhead rate. Okay, the standard quantity of the allocation base times the variable manufacturing overhead rate gives us the standard variable manufacturing overhead per unit. Okay, so in this first one, we're just developing the rate. Then the standard quantity of the base times the rate gives us the cost per unit. Okay, and for fixed overhead, well, this will be easier when you see problems, okay? The verbiage is hard, I think, to swallow. The total estimated fixed manufacturing overhead divided by the total amount of the fixed gives you a fixed manufacturing overhead rate. All right, then we take our allocation base times the rate, gives us a standard fixed manufacturing overhead per unit. Okay, so here's some standard costs of manufacturing overhead. The Tucson allocates manufacturing overhead using machine hours. Each case requires 0.10 machine hours. Okay, each case. Tucson plans to produce 400,000 cases using 40,000 machine hours. Okay, so Tucson expects $1 million of variable overhead and $360,000 of fixed overhead. So that's your total right there. So we're going to take $1 million divided by 40,000 machine hours gives us $25 per machine hour. Make sure you write down that later part, okay? 0.10, all right? It requires 0.10 machine hours, so 0.10 times $25 gives us $250 of variable manufacturing overhead per case. Okay, now for the fixed, we're going to have $360,000 of fixed divided by 40,000 machine hours gives us $9 per machine hour for fixed. They tell us that this product needs 0.10 machine hours times $9, 90 cents of manufacturing overhead per case is for fixed overhead. Okay. Yeah, we have to work a problem for you to see it. And here's an example, the standard cost of one unit. We're going to have direct materials, direct labor, variable overhead, fixed overhead. And these are the numbers that we just went through. I've got $7.50 of labor, $1.10 for, $7.50 material, $1.10 for labor, $2.50 for variable overhead, and 90 cents for fixed. Our standard cost would be $12. Okay. And then for sustainability, that the companies really do re-engineer their products, their packaging, their processes all the time to save environmental resources and also save money. All right. And the other thing, this results in changes to your overhead standards, and your operating cost standards also change with these changes. The other thing that they make a point of is how a company is responsible for a product through the use, through the time the consumer has it, all the way to when it's disposed of. And it's called like cradle to grave responsibility. Okay, it's a big thing in sustainability. So here's a flexible budget. If this is my standard cost per case, there's my actual cases. My flexible budget for 31,000 cases would be 31,000 times 750, 232. Okay, times $1.10 times 250, and here are my variances. Okay, you can see that the flexible budget uses the actual quantity to 31,000 cases, even though they planned 29,000. Okay. And here's problem 1. This Swirl Confectioners has rich fudge. They sell the fudge to local retailers. A unit is a 10-pound batch. Okay, standard quantities of ingredients include 5 cups of sugar at $21 a cup, or 21 cents. So 5 cups and 21 cents. 21 ounces of chocolate chips at 10 cents per ounce, 21 ounces times 0.10, and 17 ounces of butter, 17 ounces of butter at 7 cents per ounce. This stuff is getting cheaper, $1.19, and then evaporated milk is 28 ounces times 9 cents per ounce gives us $2.52, and the total here becomes the standard cost for a batch of fudge. Okay. Next, we'll take a look at computing and evaluating direct material variances.